Hello, I'm Joe Tavermina, and we're here today to talk about smart grid deployment. This is a presentation of Tav Networks, Inc. Tav Networks specializes in smart networks, and today we're going to talk about the smart grids that are being used in the utility industry, and in particular about the deployment in the smart grid area. Question for you is, what stage is your company at with regard to a smart grid rollout? We serve all of the parts of the life cycle in smart grid deployment. What I'd like to do today is to talk about some of the issues with smart grid that we've seen. First, let me define why people want to go with smart grids. The promise and the hope is that improved measurements, better equipment, and namely sensors, and better data communications will ensure a robust, efficient grid. This is the reason that smart grids are happening today. So during deployment, by the nature of the outdoors and the nature of the grid, we've got to be taking into consideration varied geography and terrain. Now, my company, Tav Networks, has been working in Northern California, and we've experienced a wide variety of terrain in Northern California, and that's representative pretty much of what people will see around the country, around the U.S., and around the world. The meter densities in California vary from 1 to 50,000 per square mile. So we have very dense urban areas and very sparse populations. In fact, half of the square miles in California have no metering equipment and no infrastructure at all. So terrain does need to be considered. Part of the smart grid, a very important part, is that effective data communications is needed to get the data where it's needed with the latency and with the responsiveness and reliability. And effective data communications is highly dependent on the local conditions and the environment for the deployment. In this slide here, for starters, we see a multi-resident building with meters located beneath the garage area there, the opening in the ground. And it turns out that in this instance, it was quite difficult to get a radio signal to the meters. So first, let's go to take a look at dense urban regions. In cities, there are high meter densities, but the meters tend to be below grade, and the distribution and transformers are also below grade. So putting in communications to the smart meter requires, first of all, going through the vaults, and secondly, finding a way to get the data and the signals out of the vault and back to the headquarters at the utility. Another issue with the cities is that there often are not poles for mounting radio equipment where radio people like to put their stuff. At the other end of the spectrum, in sparse agricultural regions, there are challenges as well. Here we've got the challenge of very low meter densities, and the meter range and the signal levels become an issue. And to complicate things further, often we find meters are enclosed in metal boxes that act as Faraday shields, and even if the signal can get to the vicinity of the meter, the metal box kind of does it in, and the signal has a tough time getting through. Mountainous regions are another area where we have hard-to-reach conditions. Several reasons. One is that many of the AMI systems, that is advanced metering infrastructure systems, rely on cellular coverage for backhaul of the data. So a certain number of sensor data and meter data is aggregated, and then a cellular modem is used to send that data over the internet back to the network operating center. And in mountainous regions, we find that sometimes there just is no cellular coverage, so other communications backhaul needs to be used. And then also in the canyons, there are many instances in California along the interstate highway system where canyons twist and turn, and it's very difficult to get from one end of the canyon to the other before the mountainside blocks the signal. Suburban apartment buildings have also proven to be challenging at times Again, we have the conditions of meters below grade and isolated from the radio network. And we have the possibility of interference and multipath that complicate the signals. And in a meter room, there might be a whole bunch of meters, and sometimes that creates a problem all by itself. And after those cases, there's just some corner cases where the meters are in very isolated places and difficult to reach. This slide shows some of the things we've run across. A local RF environment can also be a problem. So here are some things we've run across again, where a metal chain link fence, a security cage, surrounded the area where the meter is, and then additionally the meter was inside of a metal cabinet. And so we kind of had a double whammy here of getting the signal to and from the meter. We've seen instances where radio interference has been a problem, where the smart meter interfered with commercially available devices in the building, namely things like baby monitors and cordless telephone systems. And in one case, the signals from the smart meter tripped a ground fault indicator or ground fault protection circuits. There's also been instances when interference from outside sources have affected our AMI system, including pagers and cell towers. In addition to all of these radio coverage problems, there have been other issues that we've seen. Some of the common ones are the software configuration on the meter. Each of these meters is a router, and sometimes the routing is disabled. Special care is needed when we have distributed generation sources for solar or for wind. Sometimes we've seen errors in the location database. So we were told that the meter is in one place, but it turned out to be a mile or two away in a much different local environment. We've had to deal with firmware updates and failures of firmware updates due to connectivity issues and just some firmware faults. So these are all things that we can share with you in detail if you'd like. So we're done with the smart meters for now. Let me tell you a bit about who we are. We are an engineering services company, and we specialize in smart networks. And smart grid is one of the application areas for smart networks. We don't have a particular product that we try to pitch, so we are agnostic with regard to products and very open and trustworthy with regard to the advice and the direction that we might recommend. We're familiar with the challenges of smart network installations, and we have many customers who are satisfied with the work that we do, a number of utilities, and also customers from other industries. Well, before I go, I wanted to tell you and suggest some of the ways that Tav Networks might support your company in a smart network or smart grid deployment. We have studied the alternate solutions that are needed at the end of deployment for the last 10%, where we find that a single technology can run into trouble. We've found a number of ways with our field engineering staff to mitigate deployment risk that's associated with non-communicating meters. Some meters, when they're swapped out, just need to work right off the get-go, and knowing that they're going to work before they're swapped is important. We've done a network design for our customers. We've verified equipment performance and firmware, and you can see the remainder of the list here. So thank you for your time and attention. Here's our contact information, Tav Networks, Inc. Thank you very much.